All right, well, I will get started. Thank you again for joining. Great to see lots of familiar names joining today's meeting. Today is one of another 475 building blocks. Today we will be talking about the FLAIR ERV and HRV, centralized mechanical heat recovery and ventilation, heat recovery and energy recovery ventilation systems, and the geothermal preconditioning system provided by GHT. We supply the FLAIR unit and full distribution system in the 225, 325, 400, and 600 sizes, available as both an ERV and HRV, and we have compatible sizes for the geothermal systems. All right, so we are going to start out with the benefits of heat recovery and energy recovery ventilation systems, or enthalpy recovery ventilation systems. Sounds like a lot of people are savvy on this, so I'll try not to spend too much time. But what are we here today for? What's the problem with that ERV and HRV systems solve? So why are we supplying these, and why do we think it's important? So here we have this fish swimming around in a fish tank. The fish is getting sick. Clearly, jump to the fact that the tank is pretty nasty, and that's leading to the fish being unhealthy. So what would you do? Should we scrape the sides of the tank? Yes, that's probably one step that we would do. Probably in our homes, we want to clean, we sweep, we clean our surfaces. We want to have a healthy home, but we want to do more than that, right? After we scrape the sides of the tank, everything that was on the tank is still going to be in the bowl. So we'd probably remove all the water and replace it with new water. So, in that illustration, we kind of know what to do to make the fish healthy. How about with our drinking water? Again, greater than half of Americans filter their drinking water at home. We know that healthy drinking water leads to healthy people. How about the air you breathe? We spend 90% of our time indoors. Every breath we take, we are feeding our bodies with this air. So what is the quality? What's of that air that we're breathing? Indoor air quality is always going to be less than our environmental air quality. Well, in normal conditions, normal outdoor air conditions, and it's because that air is trapped. We are in it. Things are accumulating. We're using cleaning compounds, cooking, producing moisture, all of these things that can lead to an unhealthy home. So we want to filter that air as well and replace that air in our home. So again, these are just a few of the things that accumulate within our air, whether we're using bleach, other noxious cleaning chemicals, chlorinated cleaning compounds, nitrous dioxide from cooking, carbon monoxide, which we have detectors for in our home, but even at much lower doses than our detector goes off, it still could be causing health issues and headaches. CO2 we breathe out, ozone, maybe radon, moisture from showering, cooking. If we have unhealthy levels of moisture in our air, that can lead to mold, or if it's too dry, we can also lead to it can lead to sickness because our mucous membranes are drying out, and we're becoming highways for these pathogens to enter into our lungs. So we know that indoor air quality leads to better health, better performance on tests. Employees do better, students do better, and we do better. We do better when our homes have better indoor air quality, when we're sleeping. Our bodies can recover from everything that we've done to it, from what we've beaten up our muscles and stressed our body, and it's time when you sleep to rest and repair. So we want proper indoor air quality in order to allow our body to do that. Um, how about passive ventilation? So this was a presentation that I went to at the Passive House Network. It was a presentation by Jonathan Hines of Archetype from the UK, and his firm studied passive ventilation. So I like, of course, this is a classroom case, but in terms of a home, we hear people say, I love opening my windows. I do too. I love operable windows and the ability to open those up when you want to. However, is that going to be the solution to getting proper indoor air quality and proper ventilation in your home? So this is where they intentionally designed the building, the classrooms to take advantage of air and heating and cooling effects for the air to distribute. And later on, they measured and the CO2 concentrations. You can see the parts per million on the y-axis were well above unhealthy ranges, especially in the winter and fall seasons. So if we think about, okay, we love opening our windows, but are we going to do that, every 15 minutes in the winter in order to get the proper ventilation that we need? I like to add the point also, so not only, we can compare this to opening our windows, but what if I don't have a super airtight home? What if I'm not building a passive house or a pretty good home? Your home is still pretty airtight, so it's highly likely that this classroom was designed for promoting ventilation. So if you think that your home's leaky enough to get that proper oxygenation distributed, it's you're probably not. And of course, so, as I mentioned, we think about, do we want to open windows when it's cold out? We can think of situations where we've been next to not only an open window, but just a leaky window. You feel very uncomfortable. So we don't want to have to do that. We want to, as you can see in the right-hand picture, insulate that window very well and air seal that window, and then bring in ventilation through intentional routes. So at 475, as we've talked about in some of our other presentations, air control is key to having great indoor air quality and also delivering energy, health, and comfort in a long-lasting building. So in some of these other presentations, we really focus in on how to do that using airtight materials. So if you haven't checked those out, those are also on our YouTube page, so you can always rewatch those. The fishbowl scenario actually came up when I was watching a podcast, when I was listening to a podcast, and they brought up, okay, what are you going to do if the fishbowl's dirty? Clean the entire contents of the air in your home, right? It's what we're living in. But what's better than bringing that air in and then having to clean it? Of course, preventing that air from getting in the first place. So again, airtightness, but then controlling the route that the air gets in and filtering that. So that's what a mechanical balanced system can do. We know exactly where the air is coming from, and we can just place that supply location at very intentionally where the freshest air possible is located. So we'll get more into that later, but then we can also filter it. So here we see the Brink intake and the exhaust on the side of this home, this beautiful project here. The same amount of air is coming in as is leaving, and we know that. That's how the heat recovery process happens. The air goes through the core and the air streams pass each other. And that leads to neutral pressure in the home. So number one, air tightness with balanced mechanical ventilation equals air control. By controlling the air, you're also controlling moisture, because we know that air carries so much moisture. We know that the home is going to be at neutral pressure, so we're not driving moisture movement by either pressurizing or depressurizing the home, not pushing moisture into our walls as well. Um, we have better comfort because we are eliminating drafts. We know exactly where that air is coming from. We're not using an exhaust-only system that relies on replacement air to get air into our home. So that's a typical system uses bathroom exhaust-only fans and a kitchen exhaust-only fan, and that's it for ventilation in a lot of homes. That's all that you have, and then the replacement air is your ventilation. So we're controlling that. We're controlling, I'm going to skip ahead to quality because, of course, that replacement air isn't coming from your crawl space in your attic. It's going to be coming from an intentional route and filtered again. And then delivery control. So we can specifically place however much air we need into bedrooms and other living spaces and pull air from contamination sources. So where, we've seen the typical case would be bathrooms and kitchens, but then we work on many projects that have very unique spaces, maybe where the children's hockey gear is, that we're gonna exhaust air from those spaces as well. Energy control, so that you're also controlling how much energy you're using because you're eliminating leakage, the heat that's lost through leakage in your envelope and thermal bypass. And also, one thing to consider is the reason when the codes were made to determine how much ventilation was needed in a space, these heat recovery and ventilation and enthalpy recovery ventilation systems were not yet available. And so a lot of the requirements are actually lower than maybe they should be because of these big energy penalties. It was noted that, we don't want to, if we're not going to be able to heat and cool our home enough by bringing in when we bring in lots of air, that's a problem too because we need to be comfortable and we can't in order to survive we need to stay warm in the winter. So this Brink system is a centralized system. You can see that here. So there are decentralized systems, which we also sell. We won't be going into the Luno system today, but just to let you know, that's also a balanced mechanical ventilation system. All right, so now we get into some technical aspects of the Brink FLAIR system and the GHT system. So comfort criteria. So this is required by Passive House, but essentially it's making sure that at these numbers, so if your home's heated to 72 and you have 15-degree outside air conditions, that you have to be able to supply 63-degree Fahrenheit air. And so therefore we can reverse calculate that we need at least an 84% efficient unit. Here we're going to be talking about what happens when we use the FLAIR, which is a highly efficient unit, and then use it in combination with the GHT geothermal preconditioning system. So before we do that, what is a geothermal preconditioning unit? So it uses a loop in your soil. You can install it horizontally as shown in this picture here. You could also use a borehole system, just whatever works best for your project, whatever's easiest. Maybe you're already digging up the yard, or maybe you're already putting in a heat pump, a geothermal heat pump, then you can install this in conjunction as well. But here we can see that instead of, in this scenario, it's 7 degrees outside, and that air would go through our heat exchanger on the FLAIR. But instead of bringing in that 7 degrees air to heat exchange, we are going to precondition it. So that -7 degree Fahrenheit air, as you can see on the left, goes through the GHT. There's a filter before the coil there, just a pre-filter there. And then you can see the coil on the GHT. And that is where that air in the winter, in this case, is going to be heated using the soil, the heat from the soil to precondition that air to no longer below freezing. All right, so we have this here. And then we can also see, so in the previous scenario, we saw what the minimum heat recovery rate needed to be to hit that comfort requirement. Here we can see that the Brink FLAIR units have a heat recovery rate of up to 91%. So using that same equation, we can calculate that this situation uses even colder air, that outdoor air, than was used in that comfort criteria calculation. So here we're looking at 7 degree Fahrenheit outside air and using our high efficient flare unit, and we can see that we're getting 66 degrees Fahrenheit. So contrasting that with previously we were looking at 15 degree Fahrenheit supply air and only getting 63 degrees supply air temperature. So a difference there. And then we can see what the GHG can do is, so instead of instead of putting 7 degree air into the unit, we are now putting in 36 degree air into the unit. So not only is the supply air temperature going to raise, meaning you're going to have to heat and cool your home less when you use the geothermal preconditioning system, but if we're talking about winter, you are also not going to have to use the included electric preheater as much, also leading to additional savings. When we look at the summer, if we're looking at an 88 degree Fahrenheit summer day, what happens here? So we know we have a very efficient flare unit, but this example looks at what happens when you use the GHT system as well. So when you use the geothermal preconditioning system, it's going to precondition that air to 52 degrees Fahrenheit. This is all using data provided by GHT. The climate for this case, I will have to check, but I think it might have been New York City. Supplies 52 degree air, and at this point, we can think of heat recovery happening after the GHT. However, the Brink unit has a intelligent bypass, and that would be triggered. The bypass would open, that exhaust air would just be allowed to exit and not precondition and not heat exchange with that supplier, because we know the supplier is actually going to be cooler than what's in your home. And so we don't want to heat exchange. In that case, you get some free cooling, cooling from the ground here with the GHT system. So what sets the GHT unit apart from other geothermal preconditioning systems? It is, and why we selected it as to carry with the flare units, is because it has top tier efficiency. It has a coefficient of performance of 190. This comes from it delivering 8 kilowatts of heating or cooling with just using 0.04 kilowatts from the pump itself. It has a very low pressure drop across the coil. You can see the curve to the right. It's made of lightweight material and has a very durable design. It's very easy to lift. I can lift it myself. It just has a mounting bracket at the back. So very simple to install, and it also eliminates thermal bridges because it's not just covered, it's entirely made of this EPP material. It has a flexible configuration. You could have the outdoor air come into the left-hand port or the right-hand port. all you need to do is change where the filter is located, and it has a slot on each side for that. And then there's multiple options with the geothermal system, but the one comes with all these integrated components, which include an expansion tank, the pump itself. So we can see that all here. So it's um, all included. So what sets the FLAIR apart now? So here we're going to be talking about some of the features of the Brink FLAIR units and what makes them as high performance and robust as they are. So we already talked a little bit about the bypass, but we will talk more about that. Every FLAIR unit comes with a preheater. We have these duct connections that have sealing gaskets at the top of them. The display, I think, is a great feature of the FLAIR unit because it makes it very easy to set up, to program your airflows into the unit. And there's a little info button there as well, so you can see exactly what's going on, what the pressure is at the inlet, at the exhaust. Um, a lot can be seen just right there. So it's pretty easy to understand the unit, and I think understanding leads to less errors. And then we have our fans, which have ECM motors there, and with vane anemometers for balancing. We have MERV 13 filters at the supply, and the technology and the design of the heat exchanger is very elegant and made for high efficiency to get high efficiency as well. By opening the front door of the unit, you can get access to those filters, and by using a T15 screwdriver, the whole entire system can be taken apart. So routine maintenance as well as any repairs needed it's very easy to do so. So here's the intelligent bypass. Again, the system senses when conditions are ideal for that to open, and then we can get either with the GHT, that cool air coming in, or if it is just a cool summer night, that can also be triggered then for some free cooling. So the heat recovery core is going to be a counterflow heat exchanger. So as we can see here, the design of the core just elongates the time that the two airstreams can spend together, which leads to more and more heat recovery, more transfer of heat from one airstream to the other due to the greater surface area of those two airstreams. Additionally, so not only does the core help make the system highly efficient, but the balancing does as well. So by making sure that there's a perfect mass balance between the supply and exhaust air, using this vane anemometer, which is right at the end of the fan here on both fans, we know that there's a balance between the air streams, and that also optimizes the heat recovery. That means that if your filters start getting dirty, the system sees that there is less flow due to that, and the fans will actually work harder. We also have the preheater, always included. So this is a very aerodynamic design, so leading to very little resistance, and some guiding vanes for equal airflow across the heat exchanger. As I mentioned, the full color touch screen, I think that leads to a smooth install, smooth commissioning setup process. And again, that little info button allows you to see what's going on with your unit there, just right from the touch screen. Connectivity, so we have a standard PCB with every single unit that allows you to connect to a lot of our controls, including boost switches, CO2 sensors, which allow demand-controlled ventilation, an RH sensor if you want RH-triggered boosting. that can all be done with the standard PCB. It's also Modbus capable. And then we have a plus PCB, which is an additional option that can allow additional sophistication by allowing you to connect to the internet wirelessly or not, and add in connect to maybe other building automation systems as well. Um, this is a screen of, so if you do go with that plus module, which allows you to connect to the internet, you then can log into the Brink home page. It's a browser, and this is just showing some of the parameters that can be, that are collected and then can also be trended. So it's a great way to see what's going on with the unit itself. You can toggle, you can add more to this list, and then you can toggle them on and off to make it a little cleaner. I have just outside air temperature trending with supply air temperature there on the right. So you can see your heat recovery happen. You can see what happens when your bypass opens. Very neat there. And as mentioned, our optional controls. Yeah, we have the CO2 sensor here, so you can have the system ramp up. If you, most homes don't need this because it's pretty set and forget it, and you have a, the system is designed for the volume of the home, for the number of occupants, etc. But if, for instance, in our office, we use it here because we have variable occupancy rates. And so as more people come in, the system ramps up as needed. So it ramps up and ramps down. This is a touch control. So if while there is a touch control at the front of the unit, you could put this somewhere else in the home so that you can also change the flow rates this way. And you can do time of day of week settings if desired. This is a simple boost switch. And again, that can just be connected to the unit as is. And then this is that plus module. So that's it for technical details, but I am very happy to take questions at the end. Because I know there was a lot of interest in the technical details of the two units. We'll get into some designing of the systems. To preface it, the Brink team, I think this is something that not everyone knows about 475, but we can create a takeoff and quote using your design. So feel free to send those over, but we can also create one. We can help you create one, a balanced ventilation design that meets code requirements, that takes into consideration the volume of the home, the number of occupants. We can work with you based on what the use of each space will be, and then create your takeoff and quote, as well as that design. And a special note here, when also planning out a home, the Brink ERV systems do meet continuous exhaust requirements, meeting code requirements. So projects typically eliminate their exhaust-only bathroom fans, and we and do so very successfully. So not only are they continuously exhausting air from the bathrooms, and that air is being replaced, so no need to, occupants might forget to turn on that bathroom exhaust-only fan. You can be rest assured that there's some continuous exhaust and supply replacing that. But with the boost switches, you can increase those rates as well. So to more quickly eliminate the moisture in the bathrooms. This was, I think, on the accelerator, a really great presentation with Barry Price and Kramer Silkworth. Barry Price is an architect who's been doing high performance buildings for quite some time. And this is his quote, that he's been in the difficult position as an architect to be constantly defending the mechanical room, but he's when he's failed to do that, he's lived to regret it. Constantly, you might be asked for another couple inches in the living room, but if that is going to affect the functioning of the HVAC equipment, it's quite a sacrifice. Having a well designed and ducted system makes that system um, make sure that it's can run quietly. It can run that you can get the airflows that you are looking to get. If you have convoluted ductwork, ductwork might in too tight of spaces, we could think of pinching of ductwork happening. So there's many implications to not considering how things are going to be run. You want to, so his recommendation was in design development phase to coordinate that HVAC equipment, to start thinking about where's access to the outdoor air. How can I have that duct run be as short as possible? Where's the location of the freshest air possible? And then diffuser locations as well. And his second recommendation was to be proactive instead of reactive. But how much room do you need to defend? By using a unit that's compact helps you do that. And secondly, as mentioned, we want to think about where that freshest air is, and knowing that allows us to maybe place the unit closer to that, because then our ductwork can be shorter, our insulated ductwork, bringing in that cold outside air, if we're talking winter, into the unit, that can be shorter, because of course those ducts need to be insulated, need to be airtight, but if they're longer, it's more surface area for heat to be lost from the home to that duct. So you're running a longer cold duct through your home. You might have to, if there's nothing you can do to make that shorter, then you could over insulate that duct. We do see projects do that. So there's solutions. But of course, if we can be proactive, that's always better. So insulate that duct, and then also insulate our duct going to that's exhausting the air to the outside after the heat recovery core. This is sometimes not as intuitive because we know in the winter, cold outside air goes into the core. Yeah, but I'm exhausting air from my bathrooms. That's that's not going to be cold. When it's in the 3-inch ductwork, that's the same temperature as your home. But after the heat recovery core, the main duct that leaves your envelope, because the core is so efficient, that's also going to be pretty cold. So we do also want to insulate that and keep that as short as possible as well. All right. So we see here some strategies in design on how to um, increase the efficiency of the full design system. So there's depending on the home, you might do things differently. With the left-hand photo here, we can put the manifolds directly above the unit. So for this home, maybe the unit was able to be centralized, and that 3-inch ductwork is some of it's going to go to, the west wing of the home, some's going to go to the east wing of the home, and it's going to be pretty equally. The distances of that ductwork are going to be pretty equal. If you have a situation where you can't get easy access to outdoor air unless you place the unit to one side of the home, then you might want to do so because, of course, you want to keep that insulated duct short. So in this middle photo, they've done that. They've kept that insulated duct work short, and that's where the freshest air possible was. However, maybe with a long home, that could lead to very long 3-inch duct runs, some disparate lengths in the duct runs. So a strategy might be to, here they use some snap block ducting to bring those manifolds more centralized in the home, and then the 3-inch ductwork could be more could be shorter, and that can save some money, and they can be more equal in length. Note that the units are available in left or right-hand orientation. So I've noted that the unit in the first photo is a left-hand unit. You can see the manifolds, things going to the home are on the left, versus the middle picture is a right-handed unit. The manifolds, which can't be seen in that middle photo, they're seen in the right-hand photo, are on the right-hand side of the unit. So keep this in mind when designing a system as well. We need to make sure that there's enough room for the 3-inch ductwork. So that's definitely a consideration. Where can you route it? Can you route it through your walls? Can you route it in your ceiling? Where is there space? The ductwork is small and compact, and it's very nice, this home run system. It can fit in a 2x4 cavity. However, it's not just one duct running to each space in order to get the exhaust rates and supply rates that we need. It could be 1, 2, or 3 ducts going to each diffuser in order to have the airflows quiet and also achieve the rates desired. So as we can see in this third photo, we have 3 ducts going to this location. That would be more typical of maybe a kitchen space. Keep in mind that the kitchen ERV exhaust should be at least 6 inches away from the cooktop. So this shouldn't be your primary kitchen hood. This is just going to allow continuous circulation throughout the home and will be very useful on light cooking days, help with smells in there. But it's not going to be the system that you want to use right above your cooktop. On the right-hand photo, I did include this as well because it's a retrofit case. So sometimes we do see projects wanting to install a centralized ERV system, but they have drywall up. So this is what this one project did. So just keep that in mind, that you know, that you will need to find a way to route these ducts. As mentioned, we want the outdoor air to be the freshest air possible. Maybe that location is some obscure location that you won't see very frequently. Keep that in mind as well, because while if you don't have the ability to see that intake location, it likely will not be cleaned as often as desired. So by placing the intake in a location that you pass all the time, that's easy to access, it's just going to make sure that that is maintained. So we can see examples where they've gotten very gunked up, and the system's not going to run as efficiently if that's the case. So not too close to the ground, not too sources of pollution. Just make sure that that's able to be cleaned. Lastly, we'll talk a little bit about how to install the Brink FLAIR and GHT systems. The distribution system does matter. We supply a full kitted distribution system. Using the home run system often helps eliminate errors. So we are using ductwork that was designed for ventilation, that's very low resistance and airtight. So we can see, so first we have our unit, then we have our manifolds on the right. So those manifolds are going to be installed for the supplies to each room. So it takes the air after it's been filtered and conditioned, and then breaks it up into 3-inch ductwork. So we supply 5, 10, and 15 port manifolds to correspond with our different size units. And then the same with the second manifold, that is going to be all the air that's coming back from our bathrooms and kitchens that is going to be returned using the manifold to the unit. We have insulated ductwork. Again, the ductwork needs to be insulated for that fresh air intake as well as the exhaust to the environment. So whether you use our insulated ductwork or you use metal ductwork and over insulate that, again, if the ducts are very long, you may, even if you use our insulated ductwork, you might need to over insulate. If it's a passive house, check your model to see what it's telling you based on that duct length for insulation values. But keeping those short is key. The 3-inch ductwork, as mentioned, is shown here. This is available in both a semi-rigid ducting or in a flex duct option. I will say most installers do like the semi-rigid ducting because it is more robust. It's less prone to kinking. It's double layered. It has 2 walls there, so the outside corrugated part, you can pull that through stud bays. It's durable, resistant against nails tearing it, and then the interior is nice and smooth and protected by that corrugated shell. So a lot of times projects do like working with that. Check with your code officials. Some projects do require a 3-inch flex duct to be used. This is a canvas-like material, and that's going to be UL rated. That can also provide excellent airflows when installed properly and when pulled taut. And make sure that there's no kinking there. So a proper install of the 3-inch flex ducts can work very well for projects, but it is canvas-like, and if mishandled on site, that could lead to tearing or damage to the ducts. So proper storage on site is also key. Here we can see our diffuser boxes. This is a 3-port again. This one that's hidden up in this wall here is a 2-port, but we only have 1 duct going to that, so that one of these ports is going to be capped off. We do recommend, another install detail is keeping these capped and keeping the top of the unit sealed as well while construction is happening, minimizing the amount of dust and debris that can get into the unit. We have round wall and ceiling diffusers. This one I would say is actually too close to the ceiling here. This doesn't allow you to get the flow hood for commissioning the system over that diffuser. So it's recommended to have the diffusers 1 foot away from corners, ceilings, cabinetry, 1 foot clearance on all sides. We have another option for the diffusers. So this is a design diffuser. We can see it painted 2 different colors here for some projects. And this one has a step function for changing and restricting the amount of air that can get through that. So it allows for very easy commissioning. And it has a magnetic front plate. So in order to change the aperture of the diffuser, you can simply pull that off and snap it back on. All right, and yes, as mentioned, duct design is important. So not only do we want to make sure that they're pulled taut, there's no tears in any of the ducting leading to leakage. We want to make sure that follow the install guides all on our website. Dylan and Chris are adding those in the chat throughout this, but you do want to tape both ends there with UL rated tape specifically for ductwork, and want to make sure that your duct runs, are not a convoluted mess of spaghetti. As mentioned, keep the system off and duct sealed during construction. Keeping it clean is important. And keep the materials protected while on site. Lastly, as I mentioned, you want enough space to allow for commissioning. So as you can see, this flow hood can get directly on top of that diffuser head and allows for very easy commissioning. The photo at the top in the middle here shows that design diffuser, and you just it has 0 to 8 listed here, and you can just change how open and closed that diffuser is using that. Or the metal diffusers, you simply rotate the screw to again change the aperture there as well. We always recommend every single system should be commissioned. We don't mandate, you can self-commission if you'd like, if you have a flow hood, but it should be done. That what does it do? It ensures that the install has been done well, that there's no duct leaks, no big tears, and that you do have the airflows, whether that's supply or extract from each room as you planned, as was designed. So just like we recommend for testing how airtight a building is, using a blower door test, using a flow hood, doing the commissioning is the way to check if the system's working. So one of the things that people like about passive houses, it's a performance-based metric. Once you test everything, you know that the heating cooling is sized properly. So we do want to check the performance of it. And we check by adding up all those supply numbers and exhaust numbers, we can check that the home is balanced. So as mentioned, we're here to help. We can design and size a system for you, help create that distribution plan. We have the full distribution system for a home run duct layout. And not only that, but we are proud that not only is the system top of its class, but we try to keep the quality to price ratio so that so for our customers. So excellent quality to price ratio there. And we're backed by the support of the Brink team. They've been supplying, working in ventilation for over 40 years and invest heavily in research and development. That is the end of the presentation, and want to thank you all for joining.